Hey guys, we have here our omnidirectional wheels. We have them diverted from the central axis, 45-degree each. We have them enumerated from 1, 2, 3, and 4. With that enumeration, that configuration, we have the 8 basic movement: up, down, sideways, diagonally, and the other 2 movement are counterclockwise and clockwise. We have the motor point of view from inwards. On this direction is counterclockwise, on the other direction is clockwise. We cut the base symmetrically on the x-axis, y-axis. If we cut them on the y-axis, one goes to one direction, in other words, clockwise, the other one goes counterclockwise. To establish the diagonal movement, in this case, we establish wheels 2 and 4, they do not create any type of movement. Meanwhile, 3 and 1, they go opposite direction. The last 2 direction, we have the rotational movement. If we want the wheels to go clockwise rotation, we establish the motors on the other direction, counterclockwise. And the same is gonna be for counterclockwise. The motors are established on the opposite direction. We have the motor point of view looking inwards. But if you have the motors established outwards, if you have all your motors after the wheels from the center, if all of your gears are paired on a simple drivetrain, just invert the direction.
On the rotations issue, we have 3 cases where all magnitude and directions are the same thanks to the special kind of wheels called omni wheels. In the first case, we have a square structure base where the center of rotation is the same of the square, and this is thanks to the formulas here to obtain it. On the second case, we have a rectangular base where we had to modify these formulas in order to obtain the center of rotation. The third case is special because if you can see, the width of the front wheels is less than the back wheels. So we have to modify again the formula specifically for this case so we can find the center of rotation. And if you can see, the rotation is lower than the center of these axes.
One of the ways to build a sandwich or a module for the wheels is to put a standoff on the x-axis. The standoffs on the axis make it more rigid because of the many points in which the C-channel is having contacts on. But the base is shorter, the y-axis standoff, which makes it more flexible because of the different points which are not all aligned on the same C-channels. But the base is taller by twice because of the additional standoffs and the C-channels. Y-axis standoffs allow for compressed C-channels. The C-channel on top will always secure the wheel from the whole C-channel actually from falling out. You need much longer C-channels than on this compressed state, and you would need a longer standoff as well.